Mr. McKay,
Hi.
are transformations easier than what we were doing before?
Kind of. We've already done a little bit of them when we did trig graphing. You've actually done transformations a whole bunch of times. It's just now we have to formally do things. Um, the old math curriculum used to actually do transformations kind of starting in grade 10. So you saw some of the stuff that we're going to do now a while ago. Or well, like you can transform any function that you do, and the old one they used to do quadratics in grade 10, so you started talking about that. Um, you've done transformations or how some of the stuff works when you did quadratics in precalc with vertex form, because that piece in the bracket is a horizontal translation. The piece at the end, the I can't remember if it's H and K or P and Q or whatever letters. Um, and then you had your vertical stretch to make it taller, and you have your reflection. So that's what transformations are. So we've got we're piling through. Um, hopefully everyone had a good weekend, relaxing. Um, if you have young siblings, I can I'm sure you can empathize. Although it's getting nicer, and we're starting to be able to take kids outside and not freeze to death. And Ben has a bicycle, which he likes. And the way the province is going, who knows? They might start to lift a little bit of these restrictions, and you might be able to see some people, but just don't do silly things and whatnot. So, housekeeping stuff. I haven't been able to. I think we talked on Friday. I've got two classes that I talk about similar things um, about in the calendar. I haven't figured out how to do like Monday, Tuesday, Thursday, Friday, I think is what both classes a lot of did, just because I don't want to keep overwhelming and doing that. And I'm going to try to keep these to a half an hour or so as best as I can. But you may see the calendar change a little bit. Technically, your first assignment is still in there. I've got some turned in. I've had a couple people email me about, oh my gosh, I'm working a lot, or a number of different things. There's a due date, but with this whole situation, if you're trying to get credit, oh, I should look at that form. Sorry. If you're trying to get credit, you've got to do stuff, and I have to be able to check boxes. Do you have to do everything perfectly? Well, in this situation, no. And as long as you're participating and kind of doing as much as you can, because I'm not able to give feedback in class. I'm not be able to give feedback on an assignment before, and there is no test. So the more stuff you try and send in, the better things are going to be. So transformations is the next thing we're going to look at. There's a bunch of stuff in there. So just to kind of keep things easy, because I'm not the most organized, I've put a folder that I will put all of our transformation stuff in. RF1 is just the technical outcome for the curriculum, and transformations is 1 to 4. So what we're going to go through today, which if you've looked at it, the first handful of stuff is really just some information, and then we'll look at mapping rules and switching back and forth. We've done transformations when we did trig graphs. This is what we did. We had an amplitude. Amplitude is a vertical stretch, a vertical translation moving the sinusoidal axis. We're going to see these sorts of letters again. We're not going to see them in the same sense as a trig graph, but we're taking a function and transforming it. We're going to look at reflections. We're going to look at horizontal stretches and horizontal translations. With trig functions, because they repeat, it's the horizontal stuff is a little bit harder to see and do. Um, and that's where I talked. Um, I can't remember which section. I think this would be in period one's folder. What you did with quadratics, and then we will. I thought we had something where we had notes on everything together, but I could be wrong. With trig with an actual real function, it's really easy in my mind to figure everything out from a graph. With the kind of random things in this section, just because of time, we'll actually go back when we do different things. But we've looked at these before, so hopefully all we're doing is just moving things around. So this is a little thing that Mrs. Legier had. So if our original function, well, apparently I switched that to yellow. If our original function is this red thing, to go from here to here, that's a vertical translation. To go from here to here, from the red over to here, that's a horizontal translation. These two are reflections, not FER, REF. And then this big thing down there is because it's longer and taller than the original, this one actually has a horizontal stretch. It has a vertical stretch, and technically going from there to there is a vertical translation. So you can do these with tables of value. This is one that she had a picture of. The absolute value function is this blue one. If you take the absolute value and move everything down to, the graph goes down to. If you move everything,
I can't see the screen.
what?
Yeah, neither can I. I was so confused for a sec.
Well, nope. Sorry, that's straight up my fault. Thank you for shit. Sorry, it's Monday.
You should start recording it too.
Well,
So
oh,
you can like.
it's been recording, so you'll be able to see all of that. But Captain Moron. So sorry. This is what we did in. No, that's me. I'm sorry. I I made sure I recorded, but I didn't share the. I thought I shared the screen first. So we're all still here. Everybody seemed to get quiet. Everybody still there? We still good? Okay, good. I just was a little bit perplexed. Well, that we've done transformations with trig. This is when we did writing the equation. Your A is your vertical or vertical stretch. Your B is your horizontal stretch, your horizontal translation, and your vertical translation. So when we do these in terms of general functions, we like this was the image that you were all supposed to see. Moving up is a vertical translation. Moving over is a horizontal translation. There's two different reflections here. And then this big thing down here is it's longer than it was. So there's a horizontal stretch. It's taller than it was. So there's a vertical stretch. And technically it's slid down. So now here's the picture that Mrs. Legier in her wonderful handwriting that I could never draw something like this on chart paper because the base function, and we're going to talk a lot about base functions. The base function is any function you have dealt with so far. Quadratics, y equals x squared. You've dealt with the absolute value function. We've dealt with sine and cosine. Technically, we did the graph of tan of x, the tangent function. You can transform that because it's got asymptotes. It gets kind of tricky, um, but it's still doable. So this particular one here, the blue graph is the absolute value of x, and she has a table of values. If you take the absolute value of x and subtract 2 from everything, it goes down 2. So we have a vertical translation. If you subtract 3 from the inside, the x value is minus 3, you get a horizontal translation of positive 3. And really, this is the big thing. Translation changed the location of the graph. And that's all that translations are. we've been talking about my wife has to go pick up a fancy chair from her office because they're all occupational therapists. Apparently, she has $1,000 chair. I have my old hardwood one from the 1970s, which in my opinion is better. So I might change different things. This is stretching, vertical stretch. Everything gets taller and skinnier. A horizontal stretch, it spreads it out. So we are looking at changing shapes. So I don't know what just happened there, kids. I don't know if you guys could see that, everyone running away. Uh, we're going to talk. That's distracting enough for me. I don't know what you guys can see, so I don't know if you just saw three people run back and forth across the house. We're going to talk about a function, f of x. What that function is doesn't matter. It could be quadratic. It could be um, an absolute value. It could be a sine. It could be a cosine. We're going to look at eventually exponential functions, logarithmic functions, the radical functions, whatever.
Mr. K.
Yeah,
This is gonna be all up on the files, right?
yeah.
So I'm not gonna copy it down.
No, oh yeah, no. Like the first, I think, three or four, these are all kind of in general things. And it's stuff that we've actually done before. Translation. Translations are the first thing. We have vertical, which goes up and down, horizontal, left and right. These are, any translation is an addition or subtraction. So we did this with, or we did it with sine and cosine. If we had y equals sine of x plus 3, the sinusoidal axis went up 3. You did it in pre-calc 11 with quadratics, where you had, if you did y equals x squared minus 3, the vertex goes down 3. And most functions have these key points. Trig is a little bit special, but we have still had technically those 5 points. Horizontal translation is h units. The sign, the key with horizontal stuff is everything is backwards to the sign. So we did, when we did sine of x minus pi over 4, this meant it shifted everything pi over 4 radians to the right. This is where Lauren asked, is this going to be easier? Well, kind of, because you've done a lot of this. We're just going to put it in one different thing. So we've done translations. We've done stretches, whoops, which are multiply. I didn't put divide there because fundamentally multiplying and dividing are the same thing. In pre-calc, you did quadratics, y equals 2x squared. My analogy, I think we talked about it in foundations a little bit. If you take your size and you double your height and keep the same weight, you get tall and really skinny. So it takes the parabola and makes it nice and skinny. With parabolas, horizontal stretches really don't come into play a lot. But when we had, like that was your A, your B. Did I mess up those letters? Oh, H and K. Interesting. I don't know if we're going to go back to A, B, C, and D, or because when we did them, this was D and that was C. I don't know if the terminology changes. This changed if we had y equals cos of 2x. We had a horizontal stretch of a half, so we could take the period and figure out, and that this one stretched it. This one had a different period. Period is 2 pi times b, I think. So that one stretched it out quite a bit. Things that we've done. Reflections, we talked about a little bit. Quadratics, it's easiest to see if you have y equals negative x squared. this is going to open down. The reflection, and that's a reflection across the x-axis. So a normal parabola, horrifically drawn, opens like that. If I reflect it across the x-axis, it's going to open down. For parabola reflecting it across the y-axis, if I reflect this across the y-axis because it's symmetric, it doesn't do anything. For cosine, because cosine starts at, oh dear, let's try to freehand this. Cosine goes like this, but it goes back. It's got the same symmetry that a quadratic does. It doesn't do anything. This is where this is going to affect an odd function and not an even function. We'll talk about reflections quickly. So we're going to have, and this is just another summary page, y equals f of x. That's our base function. For the next few days, I don't care. We're just going to have a bunch of points. We need to be able to identify that this is our vertical stretch. This is our horizontal stretch. This is our horizontal translation. And this is our vertical translation. And we did it with sine and cosine. So it's fundamentally going to be the same idea. 1 over b, the negative b reflects across the y-axis. This is a horizontal stretch. H is a horizontal translation. This is just kind of a map. So I know that's been kind of fast and furious, but now that everybody can see, do we all recall, or at least some of you recall, seeing some of this? Hopefully. So far, so good? Yes? No? Maybe? Let's. Oh,
With that,
yep.
did you say that this will all be like on our we'll be able to see these notes afterwards?
Yeah. I put PDFs, and I'm going to do the same thing every day. Is I'll just put them as a PDF and say here's this file completed with all of that. So what we need to do today is state the transformations, and that's going to help us with the thing that we talk about next, are called mapping rules, which is basically a set of guidelines. So if you're given a function, this is a function of x, I don't care what it is. And this is what we did, some horizontal stretch, vertical stretch, horizontal translation, vertical translation. And these are, whoa, that was supposed to be a y. And this is all, it's going to be the same format. Technically, I need another bracket there. So does this have an a value? Yep. So based on the fact that your a is your vertical stretch, this one has a vertical stretch of 3. So it's pulling it up 3 times. What's going on? Okay, it's back again. Sorry, airliner. Is there a b value, which is your vertical or horizontal stretch? There's no number in here, so it's 1. It's the same thing that we did with quadratics. If there's a stretch and there's no number, it's 1. If there's no translation, it's a 0. So is there an h value? Well, that's horizontal stretch. This is horizontal translation. So this is -4. So when we put it over here, we have a horizontal translation of +4. Sorry. And a k value, this is our vertical translation. So this is +2. So this moves for units to the right. Just moves 2 units up. And this one we can say it's taller, whatever thing it is, than the original base function of y equals f of x. If it's a sine or cosine, your amplitude becomes 3 times larger. If you have a quadratic, it's 3 times, skinnier than the rest. Even though we haven't specifically talked a lot about it, but when we did the equations from the graph, that's what we talked about. For a sinusoidal function, horizontal stretch affected our period, amplitude, sinusoidal axis, and this was our start point. We called it different things, but fundamentally, these all kind of are the same thing. So our first thing is that we need to be able to do, and we'll look at practicing some of those, is identifying transformations, which I know you've all done, so I'm not super worried. The next thing is what's called a mapping rule, and this is the one thing that we used to do that in 9 and 10 that we don't do now, which is a bit of pain because it's so nice and neat. If you have a horizontal stretch and a vertical stretch, this says any point, I'm going to, if your original point is 2 and 4, and you have a mapping rule, it maps to different things. And we're going to look at apparently 2 things. If you have the horizontal translation and vertical translation, I've got to be cognizant of time because Brittany has to go to Grand Bay and she's taking Ben, and it's, yeah. We may end a little quicker than we normally would. So what we need to be able to do here is translate. The vertical stuff you just move over, the y part. The horizontal stuff you've got to flip over. So if I have this function, we have a horizontal stretch of, oh, sorry, I'm just going to do them as they come. This one has a vertical stretch of 3. It has a horizontal stretch of the number in the denominator, so 2. It has a horizontal translation of positive 7 and a vertical translation of positive 4. So any x and y ordered pair on whatever that graph is going to map. We do x first, our horizontal stretch. We flipped it over. This mapping rule is going to map to 2 times whatever that x value is, plus 7. Our vertical part is, our vertical stretch is 3. So 3 times the y value plus 4. So down here it says if I take the point A, which is 6 and 10, and map it to, and going back to grade 9 with Madame Hayes or Mr. Hopper or Mrs. Waters or whoever taught grade, we call A prime. What a mapping rule says is I'm going to take any x point, well in this case it's 6. 2 times 6 is 12. 12 plus 7 is 19. So if I've taken that point, put it through that set of rules, and my new ordered pair would be 19. 3 times 10 is 30. 30 plus 4 is 34. So it tells me where to move whatever point that I want to use. This one has a vertical stretch of 1/2, a horizontal stretch, well, it's the reciprocal, so 1/3, a horizontal translation of -4 and a vertical translation of -1. So the mapping rule, we're always going to start with x and y, goes to the horizontal bit, 1/3 x minus 4 half y minus 1. So the first thing we need to be able to do is identify transformations, which I know you can all do. Then this is the kind of new bit, putting it into a mapping rule. And like it really is as simple as this. You're going to flip the b value, change the sign of the now h value, and then the y part you just read as is. So if we have 6 and 10 as our point, 1/3 of 6 is 2. 2 minus 4 is, once I get a pen, -2. A half of 10 is 5. 5 minus 1 is 4. So if this was a function, I don't know, whatever it is, and that point was on the graph of the base function, so this is our, get away, base, and this is our transform point. So that's our kind of the gist of what we want to do. So well, apparently we're at page 10. So this one has, here's a mapping rule. Where are the points going to be transformed? And then what are the transformations and what would the equation be? So this is probably the last thing I'm going to do. You can take a look in files. The next one is practice. Start conversation. So these are different things. I'm going to go through parts of this tomorrow. Like I'll go through the first part and do a couple of those, like a couple of each of the questions, and then leave it to you. Once I figure out how to take Wednesday out, we'll be all right. So we have a mapping rule. We've got point. This is A, B, C, D. And I'm told this is my function. If I put this under a mapping rule, what are the new points? Well, 2 times -5 is -10. -10 plus 4 is -6. A half of 6 is 3. 3 minus 5 is -2. And if I make an arithmetic mistake, please correct me because I don't want to. So -6 is here and -2. So here is A prime. B prime, 2 times -3 is -6. -6 plus 4 is -2. A half of 2 is 1. 1 minus 5 is -4. So -2. And this is B prime. 2 times -1 is -2. -2 plus 4 is +2. A half of 4 is 2. 2 minus 5 is -3. So over 2, down 3. 2 twos are 4, plus 4 is 8. A half of 0 is 0. And minus 5 is -5. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So, oh, I forgot. This is C prime. This is D prime. Line. Oh, well, I want it in red because it's the same. So the base function is the blue one, and my lines aren't going to be perfect because I suck at this with the pen. This is our transformed one. So we have a mapping rule. The horizontal translation, whoops, the string is getting in the way, is 2. No, the horizontal translation is positive 4. The vertical translation is negative 5. The horizontal stretch is 2. The vertical stretch was a half. So this is A, B, H, K. That should be lowercase. So we need to be able to translate that. So our A value was a half. The B value is 2. I forgot that's 1 over B. So 1 over 2 x minus h, so minus 4. And that is, I'm sorry, we're almost done. Kate's been upset all day. So that is a quick introduction to transformations. Hopefully we remember and can make connections to the stuff we've done with trig. Technically, I could write mapping rules for every quadratic you did in pre-calc 11. Or in foundations, it's a little bit trickier because we don't use this kind of, well, you talked about it as vertex form. But what we'll go over tomorrow is a few more examples of translating one to the other. And that's the basis of transformations. We need to be able to go back and forth. Technically, we're supposed to be able to go from a transformed graph to a regular graph, which is more complicated with these ones. It's actually easier with a real function. So I'm going to save that. I think that was the 10 pages that I posted. And tomorrow we'll pick up with the next one, which now I can't find quickly. Maybe. That's somewhere in there. We'll figure it out and do a little bit of practice and with, oh, there it is. So this is where we're going. If you want to do the first couple of each type, you can. I'll go over them, and then that will be kind of the practice. Eventually, there'll be some sort of assignment that will probably look very similar to this, identifying what the transformations are, writing mapping rules. What is it going to do? But that's kind of our path for this week. So are we okay with that? Any questions?
This is way better than what we were doing before.
I'm sorry, Lauren. I'm glad that you're feeling better. Well, trig identities are like I taught them years ago. I always used to go into Mrs. Legier's classes when she would do them, and they're very different because they're open-ended. It's applied algebra. There's no actual real reason to do them. My father-in-law was over here dropping something off, and I had the computer open. He's like, "Oh gosh, I remember doing those, but I have no idea because if you don't use them, and technically, unless you're going to be an engineer, and even an engineer wouldn't use them on a daily basis, you use them in courses as you go. But because there's not a lot of people that just straight up do calculus or trig on a daily basis, but it's applying a whole bunch of rules that you know and trying to solve problems, which fundamentally is what every job is. It's not necessarily going to be with trig, but
So what you're saying is we don't really have to do the assignments, and it's not really necessary.
If that assignment was the only assignment you didn't do in like from here on out, you would still get a credit. But if you're going to take calculus, and especially if you're going to take calculus past like a first year calculus, which is any science or engineering degree, you're going to need to be able to use them to some extent. But it just because of this horrific situation that we're in. It's what I did in 4 or 5 days last week is what I would spend 2 weeks in class, and you would have all sorts of time. And a bunch of you, because I know you would have come in and said, hey, I don't see this question, and I would have poked you in the right direction. So, but I've got to run because Brittany's taking Ben for a drive. So I have to look after Kate. I will post this. The second set of stuff is up there. Excuse me. And I'll try to figure out a way to kill that Wednesday thing, unless everybody really wants it. But I just thought, excuse me, 4 days would be enough. So I will see everybody tomorrow, hopefully.
Wait, what days are we meeting?
Pardon?
What days are we meeting?
Monday, Tuesday, Thursday, Friday was kind of the consensus, I think. So just dropping the Wednesday thing. But if everybody, if there's a whole bunch of people, like I said, I'm flexible and we'll work our way around things. So I'm gonna stop sharing.
Thank you.
Thank you for coming. Hope everybody's having a good day. Enjoy the sun. See you later.